Hi, I'm Brandon Gracey. I'm a high school math teacher. We're going to talk about how to multiply monomials together today. A monomial looks something like this. There's a numerical coefficient and there's possibly a variable component as well. Now the number out front here could be any number at all, and this variable component here could be any combination of variables, and it could actually have no variable. It could just be what we call a constant, just a number with nothing that's variable, nothing that changes. And so if we want to multiply two monomials together, and I'm going to write them in brackets to show multiplication, we might get something like this. Here's 11x squared. So 4x times 11x squared. And the way we do this is very straightforward. We're going to multiply the numerical coefficients together, which we usually just call coefficients. We'll multiply the two coefficients together, and then separately we'll multiply the two variable components together, and that's how we'll get each piece. So let's start by multiplying 4 times 11. I'll put this in oops, I'm sorry, purple it is. I'll put this in brackets here. 4 times 11 is going to be the numerical component, the coefficient that's going to be out front of our new monomial. And then I'm going to multiply the two variable parts together here, the variable components. I'm going to do x times x squared. I'm using the dot to represent multiplication because then it doesn't get confused with my x's. So let me just show you here. There in red is the coefficient portion, and there underlined in green is the variable portion. So together this gives us 44 as the new numerical coefficient. And here we just have done this, the exponent laws, so we know that there is an understood 1 right here, and then together I should get x to the exponent 1 plus 2, which is x cubed. So I've got 4 times 11 is 44, x times x squared is x cubed. So that's how this works, and that's really all there is to it. So let's do a few more examples and we'll try to get some that are a little more challenging. What if I have something that's written like this? Now here is one monomial, and here's the other monomial. There are two pieces there. They're being multiplied together. The multiplication is right in there. That's multiplication because we have one thing juxtaposed or stuck up against this other thing, and we use brackets whenever we have numbers. So 4 times negative 10 is negative 40, and then the variable component here is sort of missing. It's not variable. This is a constant, and so this is sort of like 1 times this thing here, which is x to the 4th. We have 4 times negative 10 to get negative 40, and x to the exponent 4 is all that's left for the variable component. So that's how we multiply those two. Now this works for more than just two monomials, though. It works for any number of them all stacked together. I'm multiplying all of these. So I have 5x times negative 2x cubed times negative 3. And so the number part of this is going to be 5 times negative 2 times negative 3. I'm going to write that in a set of square brackets to be really clear. I have 5 times negative 2 times negative 3. That's the number part, the coefficient that will sit out front. And then I'll have another set of brackets here for the variable portion. I have an x, I have an x cubed, and that's not variable, that's a constant. So I'm just going to leave that one, or I could multiply by 1 if you like, but it's not really necessary. So in here, by multiplying these three numbers together, I'll get the coefficient. 5 times negative 2, that's negative 10, times negative 3 is going to be positive 30. In my own brain, the way I do this, I do 5 times 2 times 3. That's going to be 30. And then I count my negatives. I have an even number of them, so I will have a positive result. Now here, in the variable component, I have an x and an x cubed. An x, you say, yes, one of them, there's the understood 1. That's x to the exponent 4 once again. Okay, now if there is more than one variable, what do we do? So what if I have something like 2x squared y multiplied by negative 3xy to the exponent 5? Well, the coefficient is going to be 2 times negative 3. I can do that one in my head. That's negative 6. Now let's look at the variable components here. I have some x's and some y's. So I'm going to have an x to some exponent, and I'm going to have a y to some exponent. Let's see what they're going to be. The x portion will be 2 plus, oh, there's my understood 1 again, 2 plus 1. will be the exponent there. And on the y, oh look, another understood one. 1y here and 5 of them there. That's 1 plus 5 is 1 plus 5, I'm thinking ahead, is that exponent. So altogether that gives us negative 6 x cubed y to the exponent 6. Now when you get good at these, you can sort of quickly look and count. 2 times negative 3 is negative 6. How many x's? 2 plus 1 is 3, and you would just write down x cubed. How many y's? 1, and 5 more is x, or y to the exponent 6. So that's all we do, is if you know your exponent laws and you know to go from x squared times x to giving you x cubed, then you'll be all set. Just deal with the numerical coefficient on its own and then deal with the variables on their own separately. Okay, and that's all. Thanks a lot.